and zoom up to the top.
That's the way it goes. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Jenny List.
This is episode 358, Soft Displays, LCD Apertures, and Mind-Controlled Toys. This week, Jenny is coming to us from the high seas.
I'm on a North Sea ferry.
So if you hear any bar noise in the background, I guess you're in a family-friendly bar.
Yes, very much family-friendly. I can thoroughly recommend the hospitality of Stena North Sea ferries. I'm a great fan.
The big Hackaday news this week is we're announcing Hackaday Europe. Call for proposals is on. Tickets will not be on sale for probably another month or so, but we're moving.
Yay!
We're moving in all four dimensions. We're moving to Italy. It's in a little town called Lecco, which is where the Politecnico Milano is. So there's a engineering university there, and they have kindly let us use their space. But we're also moving in time. It is May 16th and 17th. Show up the night of the 15th. We'll go paint the town red, and then start up with the conference for real on the 16th and 17th.
It sounds absolutely brilliant. If you don't know where Lecco is, it's on the right-hand arm of Lake Como. So it's actually in a very, very nice part of Italy. I was looking at it on Google Maps the other evening, and I'm very much looking forward to going there, not just because of the Hackaday thing, but because it looks like a very nice place to go.
Yeah, it looks absolutely fantastic. It's a town of 45,000 people nestled along the side of the lake with mountains on either side.
It looks absolutely lovely.
It's kind of the polar opposite of Berlin, where we've been having it in the past. But that's not necessarily a bad thing.
Yeah, I've loved our trips to Berlin. Berlin is amazing. It's awesome. But to go here sounds really fun. Of course, I'm imagining myself in some sort of uber glamorous life lounging by Lake Como, when in fact I'm going to spend a day and a half in some sweatshop to get all the badges working and probably never see any of it.
The badge is going to be the same badge we ran for SuperCon. It's going to be the communicator badge. So I think we've got it basically under control.
In that case, Elliot, you'll find me down by the beach in a nice bar.
First round of Caparis on me.
So genuinely, it looks like a great event coming up, and I'm really looking forward to it.
Can't wait. Again, tickets will go on sale probably just after we make the selection for the talks. Get your talks in now, though. You've got until just about a month, March 18th, to get them in. And then we'll take a week or so to decide. And then tickets will go on sale. Probably early bird tickets right around then. And again, if you submit a talk, we'll get you an early bird ticket, because it's not fair for you to miss out on them just because you submitted a talk.
This is a journey into sound.
What's that sound?
What's that sound?
Well, then let's head on off to What's That Sound. You're absolutely going to get this one.
Oh, okay.
The introduction starts like this. Space, it says, is big, really big. You just won't believe how vastly, hugely, mind-bogglingly big it is. I mean, you may think it's a long way down the street to the chemist, but that's just peanuts to space. Listen. And so on.
I am a child of the 1970s, and I was born in the United Kingdom. So I have something that probably not many other Hackaday readers have. I was actually there sitting listening to Radio 4, because my parents always listened to Radio 4, back in, I think, 1979 or whenever it was, when the first airing of The Hitchhiker's Guide to the Galaxy happened. So I heard that one before you did.
Yeah, that's probably true, actually. Yeah, my wife suggested this one, and I was like, oh, it's way too obvious, but I love it so. We're just going to put it in anyway.
The original BBC Hitchhiker's Guide is, to me, the definitive Hitchhiker's Guide, because it was a BBC radio drama series before it was anything else. And because I was there to hear it when it was first aired, I'm going to stick to it. It's like hipsters who say, oh, I was into it before it was cool.
That's right. As Tom suggested, this is going to be like a test to see how many of our listeners will write in if everybody knows what it is. And that's basically right. One of the commenters said, hope you have a 1,000-sided die. Well, okay, so it wasn't that bad, but almost. Let me just say, this is the first time everybody who wrote in got it right. We have 121 submissions, 119 of them are correct, 2 of them are duplicates. But every last person, 119 out of 119 legitimate answers are correct on this one.
Well, the correct way to do this, Elliot, is to throw 7 coins and get a binary number.
What, 119? Okay, I'll do it. You've got me. I'm lacking a coin. No, that's not a good idea. I was going to throw a coin cell, but that's a bad idea. It's probably not balanced. I'm going to get a coin. I'll be right back.
I'm really sorry. Listeners, I am sorry.
It would be funny to throw a coin cell, but I bet it lands positive every time or something.
Probably.
Yeah, here we go. What is this? Oh, this is...
Has Hackaday ever done a challenge coin?
No. Oh, we should. I don't even know who's on this one. Oh, it's Sally Ride. Oh, that's cool.
Ah.
U.S. quarter from whenever, 2022. And it's got Sally Ride on the back. So we got heads
Impressive.
And Sally Ride. How many do we need? It's 128,
I think it's
right?
7.
So,
7 is 128.
sure, so
Yeah,
we need to
okay.
do 7. Okay, here we go. Most significant digit first.
Now, a head's a 1 and Sally Ride is 0?
Oh, that seems unfair.
Or the other way. Sally Ride is a 1. Sally Ride is a 1.
Most significant bit is Sally Ride. So that's a 1. 164. Next up,
Okay.
Benjamin Franklin. That's a 0. A 0. So we remain at 64. A 0. So we remain at 64. Uh-oh.
Okay.
A 0. So we remain. I wonder who got number 64 here. Another 0. What am I at? 1, 2, 3, 4, 5, 6. So
Is this
so
coin
far
Ben?
it's... Boy, another one. Congratulations, number 64. And that is Moogle. Congratulations, Moogle. Despite the infinite improbability of me getting a shirt out of this, it's Hitchhiker's Guide to the Galaxy. Oh, fantastic.
I think somewhere a whale and a bowl of petunias have fallen to earth.
Oh my God, for sure. And so many people, like all of the answers in this are fantastic. You know, there's somebody just wrote "Don't panic." The answer is 42, but I gave them that one.
Yes, you can give them that one. From the experience of being either 8 or 9 years old in 1979 and hearing this, it really was a mind-blowing radio thing. I'd never heard anything like that on the radio.
Yeah.
BBC Radio 4 is talk radio. It's fairly boring for kids. And generally it just was always on the background because my parents had it on. And suddenly this like, wow thing comes on, which for a 9-year-old me was actually mind-blowing.
Again, the reason I finally was swayed to do this, even though everyone's going to get it, is that some of you out there did not hear it. And if you didn't, go listen to it. It's absolutely fantastic. Go find it somewhere online.
Can fully recommend it.
Yeah. Everyone else, stay tuned. Next week, we'll play a new sound. You will have a chance to guess. And if you get it right, a chance to win a Hackaday podcast t-shirt. Next week's going to be a hard one. All right, let's start off the hacks. My first one, real-time 3D room mapping with ESP32 VL53L5CX sensor and IMU is a perhaps overly realistic title for this project by Enrique Ferrolo. It is fantastic, though. He basically takes these 3 different modules, wires them together, and the rest is sweet software magic. The VL53L5CX is a 64-point time of flight distance measuring sensor. And what's cool about it being in a 8x8 grid is that you get kind of almost a depth map with it in a kind of a cone that it pushes out, right? And so Enrique starts off this project just kind of wanting to visualize that and makes a really nice Python interface that shows you, what the different heights are in real time in front of this sensor, and then goes from there. It gives you really good feedback, real-time feedback for what the sensor is seeing. And for instance, one of the things he notices is that the depth readouts are fairly noisy. And so he's got a little exponentially weighted moving average. You take 90% of the running average and 10% of this sample, and you put them together, and you just always do this. And that smooths it out really nicely. And he's got a little slider on the Python interface that he can, more of the current sample, less of the current sample. So you can kind of play around with sliding out the noise and see that in real time. He also has it try to estimate like planes. So if he points it at the ceiling, it can estimate where that surface is. And if he points it at the wall, it can estimate where that surface is. There's a really neat demonstration of the problems with doing this when you point it at the corner, where the wall hits the ceiling, and he gets to run through the RANSAC algorithm, which is the random sampling something, random sampling consensus. It's a sweet algorithm. I learned about it in this video. You take 3 points, they define a plane. You then see how close all the other points are to that plane, and you give it a score, and then you run this 100 times, and you pick the best one. What's cool about this is it gives you the plane that the most points in your sample are close to. And so it's kind of immune to things like having, a lamp sticking out of the wall, which if you were using something naive like least squares would, skew the plane of the wall to kind of include the lamp, right? And this way it excludes the lamp. It just gives you kind of the most points that fit on the plane. If you're pointing at a flat wall, it gives you a good feeling of where that wall is. But then the best trick, and this is at the very end of the video, you absolutely need to see it. He's got the IMU and he finally uses it. He puts the persistence of the point cloud to infinity and just kind of sweeps it around, turning it, and ends up point clouding himself. And it works remarkably well because the IMU knows where it's pointing and he can just like scan it all around. And that's where I think this has a lot of room to be continued. Because it's a gyro IMU, it's really good at turning, but it's not good at moving it around the room. Like if you translate it, it loses track of where it is. But if you just pivot it in a spot, you can kind of scan around the room, and that works beautifully. And so if you could combine the two, and I think there's some more software side stuff you could do on this to handle translations by saying, oh, there was a wall there before, the wall appears to have moved a meter. I know that I've moved the sensor a meter, right? Like there's good ways to do this, like what you do with photogrammetry, actually. So anyway, what's really inspiring about this is that it's done with dirt cheap hardware. I think he says 30 euros, $30, but I think you could do it for even less if you weren't so spendy with the IMU, or if you had like had one kicking around your junk box, which I do. And I just need this fancy time of flight sensor. People came in the comments section saying there are even higher resolution ones out there, and other people suggested that it's stray light that is messing them up. Your mileage, of course, will vary. But I just want to see people iterating on this really cool idea, because it's amazing that with kind of inexpensive parts, you can get a 3D point cloud out and start working on it yourself.
I'm seeing this as analogous to the arrival of some of the cheap and low resolution thermal camera sensors that produced an outpouring of new projects using them. I'm expecting the arrival. I hadn't seen this component until this project, and I'm expecting the arrival of this to see a whole load of people using them for interesting things. I mean, a lot of us have played around with the single LiDAR things, the cheap ones, which to be honest aren't very good, but this adds it. Oh dear, pun alert, a new dimension.
Ooh. Yeah, I mean, the temptation to put this thing on like a servo-driven gimbal and just like scan it around the room is essentially irresistible.
I can see that.
So I want to see where this goes for sure. I did know about these sensors. I actually saw them a few years back at a trade show, and they had some really impressive demos, but not nearly as impressive as this one that Enrique's pulled off. So go give it a look. I think there's room to be pushed on both the hardware side and the software side. And yeah, let's see it. Let's see it.
Next up is a hack from Ancient, who has created it. It's described as a computer that fits inside a camera lens. But what it actually is it's an adapter between an SLR lens and a mirrorless compact camera. So the focal plane distance for an SLR lens is longer than that of the compact camera. Thus, when you have an adapter, you've probably got about 10 or 15 mil worth of space that's roughly conical into which you can fit other things. Now, in most cases, it's just a space with conductors for whatever electronics for the lens. But what he's done is put a little PCB with a microcontroller on there and an LCD. And the LCD can be an aperture. It can do alternate wigglegram style side to side things. It can be a little pattern, so all your highlights have a little pattern. It can be all sorts of really cool visual effects. In a way, one of the coolest things is the choice of LCD, because it's something that older hackers will remember, but you don't see that much now, but it's still around. In the late 1990s, Nokia produced a series of phones with an LCD display. I think it was the Nokia 5100. And for some reason, that LCD display ended up on the secondary market. And for a while, it was the default display for anything you'd run with I don't know, PIC or something like that back in the day, and probably later in Arduino. And even though it's been well superseded by all manner of other displays, it's still around. And it has the advantage that if you click it apart, you can take the backlight off. You can basically end up with a transparent or not transparent, depending on what the voltage is, LCD, which is what he's done. So it's this sort of classic component has been dredged out of the past to make an entirely new thing. If you're into camera hacking, it's an impressive piece of kit. If you just like taking pictures, I'm sure most people could do some really cool stuff with this. As a piece of miniaturization, it's beautiful. I don't think I could have done it. I could have certainly made an LCD attachment or adapter for lenses, but I couldn't have as neatly packaged it into an existing adapter the way he has. So I'm very impressed with this project.
Absolutely beautiful execution, but the point isn't the computer in there. The point is the LCD screen and the funny effects you can get out of that. And they're really neat in video because you could put funny masks on the front of the lens and, take a picture, but having them able to move and change while you're taking a video makes for cool effects that I frankly haven't seen before. And in particular, it works most on the out of focus stuff. So like the bokeh, the fuzzy stuff in the background. So he has this one where he's doing kind of like the Matrix screensaver thing where it's got drops falling down. It's kind of very subtly in the background as the video is running. And it's just a sweet, sweet effect. The technical detail I love the most is he had to have some buttons to control this thing, and he had drilled some holes in the case, and then he took just regular 3D printer filament. He pushed it down on a heat plate to mushroom out one end, put it in there, and then mushroomed out the other end. So he made these little captive plastic presser buttons out of 3D printer filament. I thought that was really sweet. Boy, speaking of serial video hackers, this next one from Soy Boy, Microfluidic Display Teaches the Basics, is fantastic. He has been just exploring soft robotics. He's been doing logic circuits. In this case, he's making a display out of it, and it's really cool. 1 pixel in this display is basically a 3D printed cup with a silicone cover over it, and when you pull a vacuum on it, it dimples into the cup, right? And so that's kind of the 1 pixel here. The question then is, how do you, using only vacuum pressure, turn this on and off? And, well, one answer is you suck on it out of one port and you let air back in the other. That should be pretty easy. With 1 pixel it is, but then how do you make it a matrix? If you're doing it with LEDs, you multiplex it, right? But to multiplex vacuum lines is something else. The good news is that if you watched his previous video, he'd been working on the kind of vacuum equivalent of transistors, which actually work a lot like FETs. They have a rubber layer in between and a little channel. And when you pull vacuum on the rubber layer, it opens the channel up. And when you don't pull vacuum on it, it flaps back up and closes. So he's got kind of a vacuum actuated valve that lets it flow over the top layer when vacuum's pulled on the bottom. To make a matrix out of this, you need kind of an AND gate. You need the pixel to suck only when its row and column vacuum lines are activated. And so to do that, he puts two of these little vacuum FETs in a row. So the vacuum only flows through them when this one and that one are both activated. So only when it's row and column are activated. And then he's got a global release line that just lets air back into the circuit to undimple them when he needs to clear the screen. And that's basically it. But it is just super duper cool to 3D print stuff that's this airtight and this precise is pretty amazing. He's actually doing it with regular FDM 3D printing, but going so slowly and with such small layer heights, and actually printing a little bit extra hot and a little bit extra extrusion so that it fills in all the gaps, right? So that it doesn't leave as much of the kind of beads of plastic noodle as normal 3D printing. But like this one 4x4 array took 2 days to print, and it's kind of the size of your hand, so he's printing slowly. Anyway, there's a bunch of cool construction details here, and the video is absolutely worth a watch. But what's really fun is that it's now turned from kind of a soft robotics experiment into a logic circuits in vacuum. It's really fun just to see how the same computer concepts that we're all used to in electronics transfers over to the world of vacuum logic.
That's certainly a very, very impressive piece of work. I hope we see more from this technique, and I hope he brings us more interesting projects.
It just looks super cool too. Like, I have to say,
Yes.
at the end of the day, even though it's only 4x4, it has a certain watching the dimples get sucked in and released is just the
Yeah.
coolest, weirdest display you've ever seen. Strangely enough, we had another 3D printing soft robotics post this week. It was out of MIT. They've got a really cool 3D printer that has a twisting head. And so they use it to extrude both a soft plastic and an ink substance that they can then flush out later. And the twisting head lets them put wrappy patterns in it, and they're making soft robotics out of that. It's, the other end of the complication scale, and I don't know if it's as useful. It's definitely research in pushing out the edges of material science, but it's a cool technique. You should go check that one out if soft robotics is your jam. 2 this week.
All that rather neatly leads into my next hack, which is from Alan Reiner. And it's a 3D printed scissor jack. Now, you'll know the kind of thing a scissor jack is if you've had an older car when you needed to change the tire on it. It's like a flat thing that you do a screw up in the middle, and it slowly turns into a parallelogram, which forces the car up. And he's made a print-in-place scissor jack out of Petchy and TPU, so polyurethane. It's using a dual extruder printer, so you can have 2 different types of filament at the same time. And the TPU makes for the bendy parts that you normally do in a print-in-place structure, whereas the PETG makes obviously the rigid parts. It's a really interesting technique because while a scissor jack is a very straightforward and simple thing to understand, and there's a question why you might want to make a 3D printed scissor jack as a demonstration of what can be done and what future things might do using the same idea. It's very interesting. I think that kind of thing is, in a way, our 3D printers in our homes and our hacker spaces have kind of got to the point where they're pretty damn good. They will get better, obviously, but unless there's a sort of quantum leap, they're not as good as it gets, but they're pretty good. And just 3D printing stuff out of the same material is just yet more 3D printing. So in terms of moving 3D printing at our level forward, this, I think, is going to be one of the big frontiers, not multi-color printing, but multi-material printing for making this kind of moving item. I liked this one, so I put it in.
Alan points this out that he's been doing a lot of one-piece prints and print in place folding boxes and whatever else over the years. And having multi-material is just game changing, because if you made those hinges before out of, PLA or PETG or whatever, and you open it and close it and open it and close it, it eventually fatigues and breaks. But if you can make the hingy part, the flexible part, out of TPU, which is intrinsically flexible, and then the rest of it reinforced with the harder plastic, then you can do a lot more crazy one-piece print-in-place designs, that like fold up, or, hold things with soft grippy parts, or in this case, make a jack out of. I mean, yeah, it does open up lots of possibilities. I think you're totally right. And I think this is the last year and this year, we are just now starting to see multi-material 3D printers get affordable. Like you say, I think that is going to be a big figuring out what we can do with the new opportunities is going to be a big change in our hacker game.
In the last year, my hackerspace has got themselves a Prusa XL, and it's interesting to watch how people approach it, because people have mostly approached it because of the very big print bed. It's a very fine printer, and people have started doing color prints with it. There's some very nice two-color prints, really beautiful results. And I think people are just starting to realize that multi-material can be a thing. So I'm going to be watching this in slow motion for my hackerspace friends. Of course, most of what I print is stuff for camera hacking, so it has to be only black. That said, I'm just thinking I could 3D print a camera bellows in TPU, couldn't I? Okay, I'm going to try that.
My favorite / cringiest moment of this video, he's testing how much force he can put on this thing. The way he's designed it, when he screws it all the way tight, it's got 4 legs that make kind of a diamond shape, and when he pulls them together at 2 of the corners, right, it extends as it goes up. The worst part, he's got about 400 pounds of pressure on it, and because he's made the surfaces flat, because he's made these rectangles, it's actually locked vertically. And he's like, okay, so now I'll back the screw out and unload the thing, and it doesn't unload. And he's got 400 pounds of pressure on it, and he's like, and so he's putting a ruler in it to try to like wiggle it loose and standing as far back as he can, because if the thing goes snappy, like, you want to have glasses on, which I presume he did. Anyway, he gets the bomb successfully defused and manages to unscrew the rest of it. But like, that's one of those things that learning it at the point in time when you have maximum load on it is, that's not when you want to figure out you've made a mistake.
Of course, the difference between that and an automotive scissor jack is the automotive scissor jack is made out of steel channel, which interlocks, so you can't actually get it fully vertical. So, yes.
Well, last up from me this week is a ridiculous hack. Custom VR headset uses unconventional displays from
I love
Dooglehead.
this one.
It is a CRT VR headset, and that is just mental. It's got 2 different CRT screens in there, and to fit them in kind of a goggle format, he's using those old Sony Watchman CRT screens, and those are just fantastic. Probably 5 minutes of the video is him just looking at the way these things are built and kind of marveling in their craziness, and I do like that part as well. A bunch of people in the comments said, we used to have little CRTs that would project into your eyes in viewfinders on old,
Yes.
like video recorder cameras and stuff. Why didn't you just use those? And Dooglehead comes in and says, yeah, I thought about that. They have a very tight field of view, and it's no good for doing VR. So the reason he's using these CRTs that have kind of a 3-inch by 3-inch size is so that with reasonable optics, he can get a decent field of view on it. And I thought that's actually really cool. I think the other reason he's doing it is just because it's hella fun to do it. Anyway, the part of the magic here that is buried, it sounds like it's fun to project VR onto CRT screens, but if your virtual reality application on a modern computer using, say, Steam VR or something, spits out HDMI and your CRT screens needs to cut that in half and then project half of that in analog onto each of these 2 CRT screens, that's not easy. And actually, I want to see more details on this one too. He's got a really neat system with an FPGA that takes the HDMI in, splits it down the middle so that it can take a standard VR stream, and then creates the analog signal for the left eye and the right eye. The rest is basically simple open source VR design optics, mounted on his head. The first prototype is this cardboard and hot glue type arrangement. The tubes of the CRT are like just floating in the air above his head. And he's like, yeah, this is pretty safe, except you don't want to touch the tubes. And I'm like, yeah, thanks a lot. Yeah. But then he builds it into a nice container, and, it ends up being about the same weight as a modern VR headset. And the resolution isn't super bad either. It's 640 by 480, and he can run 30 FPS, but because it's interlaced and the phosphors kind of give you that little bit of extra glow, it's kind of like 60 frames per second. So he can run, normal speed VR video into it. And he has some demos of him playing Half-Life Alyx and driving some cars around and like Beat Saber and a whole bunch of VR apps. His main complaint is that it is entirely black and white, and that modern VR games aren't designed with black and white monitors in mind. But otherwise, it looks like it's a fantastic and, just a fun, possibly ridiculous, retro futuristic experience. His tagline is, "I made a terrible VR headset, but I think it's lovely and quirky." It's also dangerous.
If anybody is interested in those CRTs, their older brother, their bigger brother, is available still surplus second. I think they're new old stock on AliExpress. They made a bigger version which was used for entry phones and things like that. And last time I looked, they were easily available on AliExpress if you want to play with one or two, in fact. My final hack today comes from Yana. And it reminds me of back in the day, the ARRL's magazine would only take adverts for antennas if the manufacturer could back up their claims about the antenna with real world tests to stop people making crazy gain claims that they couldn't substantiate. Now they allow you to advertise an antenna with a computer simulation. Not perhaps a computer simulation like this one. What he's done, he noticed that a project for deriving some kind of optical arrangement would also work with RF. And what this is a brute force approach to designing antennas using several GPUs to do some very hefty maths. And the idea is, instead of trying to make an antenna and simulate it to see if it's any good, you go and tell the piece of software to, by iteratively testing lots and lots of different random patterns, come up with antennas that are good. And it will go away and do this. A lot of the antennas it comes up with, in theory, work and look absolutely weird. They're like no antenna you design. They're just sort of random patterns. And he actually made some of them. He hasn't solved amazing antennas, but surprisingly, they do have the properties that the software predicted of them. They look really, really wacky antennas, just sort of random blobs of PCB in random patterns, but they work as an antenna. Certainly, antenna theory is a bit of a black art. It's something I've played around with in the past a lot as a radio amateur. I know that I am not one of its savants. But I was certainly impressed by this project as a way to brute force your way into being an antenna savant without being one.
Yeah, so that's where I'm going to have to take issue with this. What I love about it is the audacity to do something this crazy. This is a person who doesn't know about antenna design saying, I'm going to design an antenna, but I don't even know how to do that, so I'm going to get an LLM to code the software to brute force the antenna design and do the simulations for me, and then, do the optimization steps here. And then actually making them and testing them is fantastic. But the antennas are horrible. if you look at the Smith charts for these, like Smith chart is one of these like radio amateur antenna design things, but basically you're aiming for the center of it where it has neither capacitive or inductive reactance and 50 ohms, which makes it couple power nicely from your transmitter, for instance. As you sweep through frequencies, it'll have a little loop in it, but hopefully all kind of stay around the center of the chart.
Yeah.
And this thing is like some kid on Adderall just took a crayon and went rah, rah, all around. They're like loops. And if you handed me this antenna, it is so sensitive to the transmitting frequency. I mean, yes, it has a tune at the desired frequency.
Yes.
But anywhere slightly to the side of that in any direction, it's just horrendous.
You wouldn't want to use one of these.
No, and what I really want to see here is the comparison of any of these antennas to like the stupid simplest dipole you could make. Because antenna theory, yeah, it can be a black art, or it can be the simplest thing in the world. A dipole is the right antenna for you 99% of the time. Just make a damn
Yes, you're right.
dipole, maybe put a balun on it and walk away because it's good enough and it doesn't have any of these weird tweaky sensitivities that these antennas do.
Yes, yeah, absolutely. You wouldn't use one of these antennas. I would actually point out that many an electronic engineer has almost sacrificed their career on deciding that they will design a PCB antenna themselves rather than buying somebody else's design. The problem with PCB antennas is they are not just a simple dipole. I mean, I can make a simple dipole. I probably first made my simple dipole about 45 years ago. You cut the arms to the correct length. With PCB antennas, you are not working with handy conductors in free space. You're working with strip lines and you're working on a PCB that's surrounded within wavelengths by lots and lots of other components. You quickly get into RF nightmare territory unless you are one of those antenna savants. So I can see why you might wish for a tool like this, but in practice, seriously, guys, just hire somebody who knows what they're doing.
Now, I'm a big proponent of simple antenna designs. If you don't need it to have incredibly tight bandwidth for, whatever performance reasons. I mean, if this is the antenna you're going to put on Voyager and it's going to need to transmit back at Earth 50 years from now, then go nuts. I cut you whatever slack you want. You can make the craziest antenna you want. For the record, Voyager's running on a simple helical antenna, the likes of which you could also make.
Yes.
Also very forgiving. But there are a bunch of these antenna designs that are just so dumb, you can't get them wrong, basically. And
yes, exactly.
This is like the polar opposite. It's walking on a knife edge and hoping not to get cut.
It's ridiculously silly, but I kind of liked it for its audacity.
But that's what you get if you have a computer that doesn't know anything about antenna design arbitrary optimized antennas for you. And actually, there's a lovely old NASA experiment when they did I think it was genetic algorithms approach to antenna design, and they had it basically bend copper wire. And so that was the parameter that could be changed in the optimization routine. So they had a bunch of different copper wires and they would put a bend at this point of that many degrees. And they just went through this iterative optimization step, and it came up with some crazy looking things. Oh, we've got a link to it in the comments. Fuzzy Fungus has the link for you. And you can see these things. They're it's like somebody randomly twisted a paperclip. But these antennas are actually also kind of hyper optimized for their frequency band. So really fun. Anyone who's done multi-dimensional optimization problems knows that you can get stuck into funny local minima if you have a sufficiently complicated surface. And here you've got a really complicated surface and a really huge design space. So, of course, you get weird stuff out of it. But anyway, fun to watch and really, really cool to see these things actually taken out of the weird theory world where they probably should have stayed and printed out on PCBs and tested. So my hat is off to Yana for that.
Yeah, I just love this, as I say, for its audacity.
My first quick hack this week comes from Oko Optics, taking photos with Scotch tape instead of a lens, and that is actually what it's doing. It's very cool. It is basically how far can you push convolution and deconvolution. So you shine a point light into the camera with a piece of Scotch tape over it. That gives you an idea of what a point of light looks like when it's diffused through the tape. And then you take a picture of the image you want. You undo that spatial transform between the point of light and the blur on the lens using a deconvolution, and you can get the picture back. What's stunning here is how well this works. You should absolutely check that out. It's heavy DSP, but it's well worth it. I mean, I guess it's just into Fourier transform space, divide, back out, but the math ends up a little hairy. Cast Pixel, new tool, makes 3D printed PCBs fast. I picked this one because it was a take on a previous hack we saw where they were printing a slightly raised layer, putting down copper tape and cutting around it. Cast Pixel's innovation here is to make a negative form that goes over the top and smushes it down over the raised bit, helping you cut them out even better. Really kind of fun. Again, I think this is the most ridiculous way to make a PCB, but it might be really fun for a one-off. And if you've got a 3D printer and some copper tape, nothing's going to stop you. And last up, Ludwin, using 3D printed breadboards to accommodate wide boards. If you have like dual inline packages, there's always that channel is exactly the right length for them. But if you have something like any of the little microcontroller dev boards we use, it's always 4 or 5 units wide, and your breadboard isn't wide enough to accommodate them. This 3D prints a special breadboard with a super wide trough in there to accommodate the microcontroller. You then pull the little tracky, clippy things out of a normal breadboard and slide them in. What I really like about this is that you can then make a breadboard kind of any size and shape you want. So people in the comments are like, why don't you just cut the breadboard in half and, space it out that way? And of course, that's a solution unless you also have dual inline package components you want to put on this breadboard at the same time. And then this is the right solution because you can have a wide part up front and a thin part in the back, all together, all neat. And plus, it just looks really cool.
There's a universal maxim in life that farts are funny, which is why there are stories that you wait for all your writing career because you just want to write them. And so here we are with the University of Maryland, who have attached a hydrogen sensor to underpants in order to measure when people fart. Now, aside from the built-in amusement of fart jokes, there's actually a real thing here. There's actually very, very little real data on farting, on how often people break wind, how much, what kind of diets and stuff like that produce what, and what the spread of different type of people is, even down to what the number of people who have different gaseous compositions. So, for instance, some people fart methane and some people just fart hydrogen. This is part of a large crowd-funded project to produce I think it's a human fart map or something like that. What Hackaday journalist wouldn't turn up on the opportunity to write about a human fart map? Next up is line-up.Then with the question, can a scan tool kill a car? Now, they had a car, I think it was a Renault, where somebody had used a diagnostic scan tool, one of these little things you plug into the OBD, and it had killed the vehicle. Fault finding ensued. They actually ended up finding out that the car had actually been chipped at some point in its previous existence, and so the firmware on it wasn't standard. And what had happened was this non-standard firmware had met a diagnostic tool and just fallen over. A while back, I wrote a thing called the Minimal Motoring Manifesto, suggesting that cars shouldn't be computers, and if only Renault had followed that, this wouldn't have happened. Finally, is the laptop we would all have wanted in 1983 from Tech Paula, who has produced what is, to all intents and purposes, a modern laptop, but it's a 6502 processor inside it running BASIC, and it's a beautiful piece of kit. I have to say, for a 6502 laptop, I would have actually wanted a BBC Micro rather than just a generic 6502, because the BBC Micro was probably the ultimate extension of the 8-bit computer. It had absolutely everything. But if I couldn't have a BBC Micro laptop, I'd have this one any day. There'll be a fight in the comments between BBC Micro fans and Commodore 64 fans.
Quick hacks.
All right, now it's time for our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I got Tom Nardi's The Complicated Legacy of Mind Controlled Toys. And I remember when these were making the rounds in the kind of early mid 2000s. A company called NeuroSky had a basically alpha wave, beta wave sensing application. And they're like, what can we do with it? And the answer is market it to Mattel, who will then make a Star Wars game out of it. Anyway,
Wow.
the long story of all of this is detailed in Tom's post here. But what's fun is that Tom actually found one of these in a thrift store by him and has given it a try. They actually work. And I think the reason this was a commercial failure, and Tom points this out, is that it was kind of marketed as, reading your mind. And, every kid in the world had this idea of thinking of levitating the ball and it would levitate. Whereas the reality was you had to concentrate, and that changes the ratio of alpha to beta waves in going on in your brain. Basically, it's an EEG, and the alpha and beta are just kind of different frequency bands of large oscillations, for lack of a better word, electrical oscillations going on inside your brain. They're useful. You can learn something about how much a person is concentrating on something with them. The problem is you can't learn much about anything else. Like, you're concentrating on something, but are you concentrating on, the pencil in front of you, or are you trying to remember something? Like, all of these kind of produce similar effects. And so that's what's both fun and hard about this. Anyway, Tom opens one of these up. There's like a little bit of a teardown here, and there's his experience with it, and also the kind of ill-fated Star Wars game that went along. Some people in my hacker space were taking these apart and trying to see what they could do to hack them back in the day. And they're actually not bad. And Tom points this out too. You can very easily get the value out of them that is this kind of alpha to beta wave ratio. What you can do with that is unfortunately kind of limited. It is cool for like a concentration trainer or something like that. You actually can change values, of something in the world by thinking differently. And that's a kind of a really cool experience. And I've played with one of these too, so I know what's going on here. In the end of the day, it's not something that I think is particularly useful. And I think that's where these went in the end. Anyway, Tom wrote this up. It's fantastic tech. If you haven't ever seen one of these, you should definitely check it out. And if you find one in a thrift store, probably pick it up.
I have to admit to completely missing out on those toys when they came out. I was probably just the wrong demographic and the wrong age, and going through a whole load of personal things. And this was actually news to me when I read this piece.
I mean, there were a few different iterations of this toy before they kind of gave up on it. And one of the original ones, I think it was the Mind Flex, but nobody put me to task on this, had a little obstacle course you could make, and it had a blower in it that would push up a ball, right? And the ball's kind of floating in midair because it's on this stream of air, and it would go up or down depending on how much you were concentrating. And then you had to turn this like rotating platform underneath it that had the obstacles you were supposed to like levitate the ball through. So it's kind of like Flappy Bird, but upside down and controlled with your mind. It was really wild, and impossibly hard to kind of maintain the height of the ball by concentrating kind of the same amount while turning this little knob that turned the turntable. It was fiendishly difficult. It was fun for me back at the hacker space, but I could see this would drive children absolutely insane.
Now, my can't miss comes from my colleague Al Williams. Al often has to recuse himself from any story involving the space industry because he's worked in the space industry for most of his career. So he knows a very good idea of what a requirement is, because when the space industry writes a requirement, or the aeronautical industry as well, it has to be written in stone, because if you mess it up, people die. And he has taken that experience to the idea of requirements in AI and vibe coding and things like that in particular. This is one of those pieces which I think I'm going to have to go back and read several times over. I read it in detail on the train as I was coming to the ferry, and I put it in because I thought, this is really interesting, but I'm going to have to sit down and go through it again. He talks about the difference between a requirement and a goal, and really managers should read this. It's written by an engineer for engineers, but I looked at it and I thought managers should read this. They should understand that when they are saying something, it's not actually a requirement because they're not defining it properly. We've all been in that position where we've been told to do something that just has been hopelessly defined by somebody who doesn't know what they're doing. And this piece really touches on that. And as I say, I'm going to go back and read it again tomorrow and probably a few times to fully understand it. And I think you should too.
I mean, the hook here is how to write so that AI can get your stuff done for you. But the truth is, this is how to write something so that a team of people can execute something for you and get it right. It's actually totally irrelevant here that he's doing these specs for an AI. This kind of, here's the spec, it has these concrete requirements, these are verifiable this way. There's a NASA protocol that he has where they have not just the requirement, but also a rationale, so why they're doing it, a verification method, so how you can test to make sure this is true, and then a verification statement. This is verified if the last block in the sequence has the last block flag set to true. You know, something very concrete, falsifiable, kind of like science. It's how can you write these requirements so that they make falsifiable hypotheses that you can then test afterwards so that you know you got it right? And he says, you know, again, he's couching it for AI, and that's because AI gets it wrong 20, 15, 5% of the time without warning. You absolutely need to put these hard requirements in if you're having some random machine generate your output. But it's like that with people too. You know, people make mistakes. And if it's high stakes, then you need to have verifiable test results. And I think that's really cool here. Some of this mentality is probably good for your hacker projects. Certainly, it's a neat discipline to impose on yourself to say, you know, what do I want to happen? If I build this thing, should it do this? Should it do that? How much of this? How much of that? You know, and try to do that. It might be fun to try, but it might also be hella frustrating. Or it might turn your hacker project into a day job.
Well, there is that, yes.
But he's an engineer. What are you going to do? Well, that wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you have any tips, send them to us, tips@hackaday.com. And to follow the links in the show, head on over to hackaday.com/podcast. And until next week,
eat, sleep, hack, repeat.
It just sounds like you're in a bar. It's totally fine.
You see, this is the living the dream, the Hackaday dream. You see, I work from a bar, you know. Oh, this is cool.
And that's a wrap.
Awesome.